for a while. I guess what really brought focus to these genre of apps was Google Wave a few years ago, which doesn't exist anymore, but features of which still are part of Google Docs. So you can see it there, but it's been around longer. Any chat or instant message application built inside a browser is basically a real-time app of sorts. Some other examples that you might have seen would be Trello. Etherpad, of course, is hugely popular. Any multiplayer game, or even Facebook, which has got real-timey features built into it now. In the past, this used to be like faked because browsers used to not support real-time technologies. So you could fake them, or implement real-time apps through Comet, flash sockets, or forever iframes, or some other some other techniques. These techniques need not be used anymore. You wouldn't want to use it because they're pretty complex, and your code becomes ugly. So what we have now is the WebSocket protocol, which solves part of the problem in a very neat and elegant way. Of course, on top of that, you can also use libraries like Socket.io, Sock.js, which give you fallback options of Comet or Forever iframe and so on, whenever the browser doesn't support WebSockets. But if WebSockets are available, you could use them. Among these two, I recommend Sock.js because its interface is closest to that of WebSockets. Socket.io tries to do its own thing, tries to do too much, so I wouldn't recommend it right away. Of course, now for the past, I think, few months, there are a lot of frameworks which give you all of this built in, plus give you a lot more. So Meteor and Derby are some of those. In this talk, what I'll try to do is I'll just try to talk about WebSockets first and building apps with it. I'll not talk about the frameworks, because they would be just too high level, and I want to show some code which isn't that high level, which doesn't assume the audience to just implement a framework and the framework does its magic and things happen for you. You will be implementing some of the things yourself. But I also will not get into the really low-level stuff. I will not talk about the various WebSocket specs that there are. So we'll just assume that we work with WebSockets as they are today. The high-by spec has been kind of formalized, so we'll just go with that. Okay, just a quick prelude to what we were doing. This includes the web apps of the 90s and also Ajax apps of the early 90s. They were basically with the HTTP request and response paradigm, wherein a client is responsible for creating a request, a server accepts that and responds to that with the response, and generally the idea is that one action is equal to one request, and this was not ideal for a number of reasons. I mean, it worked really well. You really built a lot of cool stuff with it, but it's nice that browsers are moving forward and servers are moving forward, and you can do more interesting things now. So the way you would do it with the new paradigm is that you have a persistent connection between a server and a client, and basically messages get exchanged between one client and the server, and eventually multiple clients. So each client being a user, you end up with messages being exchanged between multiple users in a real-time way. So that lets you do more things, build more responsive, not in the design sense, but in the usability sense to you, more responsive apps. And the code that I'm going to show you now is really simple. It's like maybe just 20-30 lines of JavaScript each example, and it kind of builds on itself. So I start with a smaller example, then I add some stuff to it, then some more, and I kind of show you the code diffs, and you see how it evolves through from state A to state B to state C and so on. This just a last couple of notes that I have here. The examples are fairly simple. I'm going to just show you a basic chat application. What's tricky is managing state across complex applications across multiple users, because this is something that web apps generally have kind of avoided, or not done very nicely, or not done very neatly, or done it with all kinds of hacks. Probably because mostly HTTP is stateless, so it's kind of a ripple effect of that in some sense. All right, I'll go to the examples one. The first example that I have is a simple echo application. So you have a client, you have a WebSocket server, client connects to the server, client sends a message, and the server just echoes it back to the client. The server also sends pings saying that yes, client, you are connected to me. Just a couple of notes here. All these code examples are hosted on GitHub. That's the URL there, and so yeah, so you can just refer to that after the talk if you're interested. And also, just another note, I am using pure WebSockets for this. No jQuery, no WebSocket library, and so on. But I would say that for a real-world application, use something like sock.js because it'll give you a lot of fallbacks, which will make life a little simpler for you. All right, let me just pull in my code. All right, let me just navigate. Sorry. Okay, here we are. The first example is that of an echo application. I'll just start the code. All right, I have the server running. Let me just drag in a browser instance. Let's see. Okay. All right, so just hello world, and you see that this is the message I wrote. This is the echo that came back from the server, and here's the ping. Not very interesting. What's more interesting is the code. So I'll just I'll drag in my IDE, and let's go to the first example. What I'll do is I'll show you the server first. All this code is in Node. It's for a JavaScript audience, so you don't have to be like a Node.js expert or anything. But if you can read JavaScript code and you just get the context, I think it's good enough. The first idea here is the first block of code that I'm highlighting. I'll just increase the font size of the code so it's visible. Yeah, the first block of code here is to just create a static server that serves an HTML file. I'm using the basic Node HTTP libraries, nothing fancy there. Let's hide it away. Then I use the WebSocket library to create a WebSocket server. I attach it to my HTTP static server, and I say I accept the connection that comes in. I say on connect on message, just send that message back. In this case, this is the WebSocket client to which I send back the message. I also like, oops, sorry about that. Oh well, let's see what is, okay, I guess you can see my screen now. This here is just the ping mechanism that was shown. So these things, there's an interval of X seconds and you get the ping back. This is the server. I'll come to the client now. Again, nothing interesting in the first few lines, just a form and just a list and just a function to add a message to the list. Here's where the interesting stuff is happening. I open my WebSocket connection, and on message I log it, and here I'm trapping the submit event on the form, and yeah, on submit I log it and I send it to my server. The server echoes it back to me. That gets trapped over here, and the echo gets logged as well. This is the first example. It's a very basic example. There's nothing really interesting happening except that you have a WebSocket client which connects to a WebSocket server, and you have all that code in like maybe 20-30 lines. So it's easy to read, and this prepares us for the next series of examples. All right, I'll just come back to my slides now. Okay, let's go to the next example. Example 1 was what we just saw. A client can talk to a server through WebSockets. Achieved. Let's move on. The next idea, again, the next series of examples are to basically build a chat room application. So you have a chat application with multiple rooms. and this lets us do a few things. Again, the application itself is not massive, but the idea is that it's going to contain components which would be used in really complex applications as well. So the first thing that we're going to see is we're going to look at pub/sub done in a quick and dirty way. Then the idea is to do that pub/sub properly with Redis, and the last portion of this would be to introduce some sort of a message protocol. So these are interesting ideas, and let's basically look at the code. Get this out of the way. Let's look at the code first. Yeah, I think that'll be okay. No, I'll just demo the app first. So let's see. Okay, so I started my application. Example 2 looks pretty much like example 1, doesn't it? But it's got a few more interesting things happening. The first thing you see is that it says that you're connected to a room dash. Okay, let's connect to a real room. I connect to room Srijan. Okay, I'm connected to Srijan now. Hello, I'm user 1, and then I bring in another user who connects to the same room, and now you've got chat implemented. I see that there's a bit of a lag from my screens and what you're seeing, so I'll just try to go slower if I can. So on the left you have the browser user 1 connected to chat room. Chat rooms are implemented through URLs, so sorry for the crappy interface, but that's what I did for the demo. And you have on browser 2 on the right this another user who connects to the same chat room, and they are talking. Obviously, if this guy goes to some other chat room and says something, the message will not be sent to the Srijan chat room. That's basically the application. Not very interesting, really simple. Let's look at the code. Okay, so let's look at the server first. I maximize it for you. Again, we have a static server that serves basically the HTML and the CSS. Not very interesting, let's just get rid of it. We have a store here. The idea is that when multiple users connect, we have got a connection object, and that connection object goes in this. And we also have like an object to store all the messages that are being exchanged. That's the basic idea. On request, I figure out which room he wants. I add the connection to the room. I create an object, basically a key value pair for messages, rooms, and on message, store it, and relay it back to everybody else in that room. So let's say we've got 10 users, 3 of which are connected to the Srijan room. I have their connections available here. This is the connection pool of WebSocket clients to whom we have to push the message. So that's what's being done here. Server is pretty straightforward, very interesting. Well, not very interesting, very simple, but interesting, I hope. Let's look at the client. The client is also really simple here, nothing much. The same log function to throw output on the screen. Let's minimize that, not interesting. Again, shapping the form submission, sending it, and the magic happens because of this line here. The line is exactly the same what we saw previously, but the server has been modified to only send this message back if it is in the same room. So if I'm in some other room, I don't get the message. This is like a quick and dirty pub/sub. We will do it in a better way, which is basically example 3. So the way I would like to demo example 3 would be, I think I'll do a diff that will like make more sense to you guys, because you can actually see what's changed. I'll do the diff of the server first. So okay, so what's changed? First of all, I hope you can see this. Let me just, okay, you can. Cool. So I have Redis. Okay, I need Redis running on my server. Let's see if it is Redis CLI. Okay, so I have a Redis server running. I include that. I basically replace my JavaScript store, basically objects with Redis clients. Okay, and let's see how we use that. Let me just reduce it so that it's readable for me. Okay, so I have a connection. I know which room the user wants to connect to. What we do is we subscribe to that channel. So the channel in this case is the room that he wants to be in. And when a message comes in from a user, I push it to the channel. And since others subscribing to that channel are listening to it, on message, if target channel is my channel, send it back to client. This is like a proper pub sub being done with Redis. The reason you don't want to do it in pure JavaScript, that is the example on the left, is it's really not scalable. This store here makes the previous example completely stateful. I mean, I have to worry about how to manage the store across multiple instances of my application or across multiple processes. You could cluster them, you could use threads, you could share it, but it's still not a nice way to go about it. The example on the right, however, is a much better way to go about it, because this application now is completely stateless. Redis is responsible for keeping all the information about who is in what room and so on. This application can just implement what it has to in a few lines of code. So that's kind of example 3. I can quickly show it running for you because I don't think I did that. Let's see. Yeah. Okay. So let me just stop up example 2. Go to example 3. Let's see. Node server. The example, of course, will look exactly like the previous example because the application is the same, just the backend is changed. So there you go. Two browsers talking to each other. There you go. Chat works. The fourth example is also roughly the same application, but there is an important evolution of the code which I would like to show. The concept here is to create a protocol for various actors in your application. That's the rough idea. You've got many users. You've got probably some non-human users as well, and each of these users have got different roles. So the key of your application, of your real-time application, would be to know what kind of messages each user would exchange with the rest of the guys, and who does what when a particular kind of message event takes place. I'll try to stress that with a very simple example. Here, if you can see, I'll just close it on. If you can see the diff, and I expand the font size. Here we have two message types. The first message type is for a single message in the chat room. The second message type is for a list of messages. And you need a list of messages because when a new user joins the chat room, then all the history should also get sent to him. So that's, for this application, those are the two abstractions that you can make for message types. Obviously, for a more complex application, this block here will become a lot more complex, and of course you won't have it in one file. You know, each message gets routed to something that handles it, and that basically you can use whatever patterns you like, some kind of router pattern maybe. But yeah, the rough idea is you should know what kind of message it is and what should an actor do for that kind of message. That's the key. And again, I can show you the example, but not much there in the example. I don't think there's any real diff. No, there's no real diff in the server. Just line breaks and stuff. That's not interesting. I'm noticing quite a bit of lag between my screen and my voice, so sorry about that. connections are crappy somewhere. Anyway, I'll just come back to my slides now, and I'll give it some time until you guys see it. Yeah, I hope you see it now. We've seen these examples, and let's just do a small summary of what we saw. Okay, in these 4 examples, what we achieved was we have a persistent connection between a client and server. It's done through WebSockets, which of course is very nice, which works on maybe all modern browsers. That's like already 85% of the web usage. So that's already very good. But you also have fallbacks, and stock.js is a nice fallback because it is like a polyfill. It doesn't implement its own interface. It uses the interface that WebSocket already has, and you can just plug and play, and it's going to work with fallbacks. We did that. We also saw PubSub. So point number 1 was one client talking to one server, a persistent connection between one client and one server. But that is not what you will need for a real-time app. You would need persistent connections between users. So we did that through channels and PubSub with Redis. You could use other technologies. I'm not trying to promote just one, so you can do it in whatever way you like, but Redis is a very popular way to do this because it gives you PubSub built in. And then we saw about having, or the need for a well-defined message protocols, because that's where you're really making your application. These things get interesting because often in many applications you have got multiple users modifying the same data at the same time, and that's where you would really have to have rules well defined, who has what rights, whose edit or whose modification of the data takes precedence, maybe through time or role or whatever. So that's where all the magic happens. I have another example for you, which is slightly different. Yeah, there you go. There it is. It'll be a WebRTC example. This is kind of risky for me to show because I tried showing it a few months back and my browser updated and the code that I had built did not work anymore. So I had to fix it in the last minute, but this is like really experimental stuff. The idea is that you can do peer-to-peer with just a browser. So browser 1 can talk to browser 2, and there is no need for a server, or there is a very small need for a server, and everything happens peer-to-peer. So yeah, your client becomes a little complex, well, very complex, and your server remains simple. The basic idea of WebRTC is like you can get user media in the browser. So basically the browser through JavaScript can access the cam, the mic, and so on. We will not need to install plugins. We do not need to install anything on your machine. It's fully in the browser, and this also works like on Chrome and Firefox and Safari eventually. And since Opera is also on WebKit, it's going to work there. So it's just IE that'll be missing out in maybe what? Few months, maybe a year, which kind of is sad because with Skype being owned by Microsoft now and WebRTC really killing the need for Skype, it's going to be, I'm not sure if IE is going to have it anytime soon, but it may. Anyway, you can do peer-to-peer connections, you can exchange media and cams and mics and so on, and you can basically also just exchange data, raw data. It can be text, it can be binary, so you can do, you know, very interesting things. A few caveats there: it's unstable, very early days, the spec changes a lot, and which is why probably if you don't want to live on the bleeding edge, you want to use libraries. We already have got PeerJS and WebRTC.io and so on. So those can be used if you don't want to deal with the low-level APIs that have been exposed in the browser that change a lot. However, in my example now, I have used these APIs directly. I am not using PeerJS or WebRTC.io. I'm just writing pure JavaScript code for WebRTC myself. So the code might be a little ugly, but well, it's not that bad. I think it should be okay. I'll just get the example running now. Let's see. Okay, that's my server. I need 2 browser instances, so 1, 2. And I'll just wait for my screen to be broadcast to you guys. It's probably, I don't know if you see what I'm seeing. I'll just wait for a while. I've got 2 browser instances open to replicate 2 users. That's me. And that's some other guy. Okay, so let's see. Start. Yeah, I called. The other guy got a call. He says, okay. And you're seeing the video and audio. I've like disabled audio for this, but you can stream video and audio between the 2 browser sessions. And the cool part is we'll now basically just kill off the server. We don't need the server. Boom. Yeah, and you're seeing that the application is still working. So it's purely between these 2 browser instances. And yeah, I'm pretty sure this is the way to go in the future. So that's my WebRTC example, and that's all I have for you. I just had these series of examples, and I guess now is when we can do the questions and yeah, and just have a discussion. So yeah, that's me. If you have any questions, let's just talk about it. Vinay, over to you.
Hey guys, if you have to ask your question, just raise your hand. Shoot your question to Sri. Anyone? Okay, Vikas has a question there. Vikas, I'm unmuting you. Vikas, can you hear me? Hello? Vikas? Vikas, can you hear me? Anyone else? Please raise your hand. There's a raise hand button on the toolbox. Vikas, I guess you have some questions. So apart from Vikas, anyone else?
Yeah, maybe you can just type it in the chat box. Yeah, we do have a chat box. You can just type it there and I can answer it.
I can see Vikas raising his hand. Vikas, can you hear me?
Yeah, okay, so while we get the question sorted, I can just walk you through the code for the last example. I'm not sure if you guys will be really interested, but let's just take a look. The server is really small. It's like 40 lines of code. So the server is boring. Let's close that. Let's look at the client. I don't know if you can see my screen. Well, okay. If you can, this is where it begins. The first thing you do is basically add the streams that the browser has available. So this can be your webcam stream, this can be your audio stream, eventually maybe some other kind of media. You add these streams, you make it available to PC. PC is like a pure connection. So yeah, you add the streams, step 1. Then you create an offer. An offer here is like a call is being made. So one user is creating an offer to another guy saying, hey, let's talk. Let's go to console log 3. This is where I'm listening to offers. This is being done through WebSockets because that's the way I've implemented it. So both users are connected to the WebSocket and the call is being exchanged over there. And if he accepts, he creates an answer to the offer. And yes, hey, I'm ready, let's talk. Then what happens on both the caller and the callee is that the remote stream gets added to a video player instance. That's what you're seeing over here. And basically once this is being done, the video and the audio is ready, you can have your call. That's the code. Again, for a fairly complex application, it's like under 100 lines of code on the client, which is very interesting. So yeah, these are some of the things you can do, and this is really real-time web. WebSockets is also feels a bit not fully real-time, but this is really cool because it's peer-to-peer, and your data security issues kind of are kind of get taken care of. Well, not fully, but somewhat. And let's see, what else can I show you? I can just browse through the server. Nothing much happening there. Just exchanging messages over a channel, just as we saw in the previous examples as well. Yeah, there you go. Vinay, did we get any questions?
So guys, the last few minutes, you can ask some questions. I guess Sri, your demos was self-explanatory.
Oh, cool. Always nice.
Yeah. So if in case people want to write to you, your email ID is srirangan@gmail.com.
Yeah, let me just put out that slide again.
Right.
Well, I don't know if you see it. I have it on my screen. It's srirangan@gmail, and the website is srirangan.net, and Twitter is @srirangan. So if you need to get in touch with me, these are my coordinates.
Okay, Sri. Nice talking to you. Thanks.
All right,
Thanks for being here. Okay.
Thanks. Have a nice day. Bye.
Okay, bye. So thank you guys for attending the webinar. If in case of any query or feedback, just write to us at webinars@srijan.in. Bye. Have a good day.